Hello, hello, hello. Did you have a nice little break? Did you have a coffee? Did you stand in line for a really long time for a coffee? Or did you discover the coffee machine upstairs that nobody knows about? Because I didn't wait for coffee, I just got one. So tip for the next tightly packed coffee break, there's very accessible coffee in front of the studio stage upstairs. I think our two next speakers are still being hooked up, so this is us clowning around to stretch some time. Damn it, you messed me up. I had a thing that I wanted to say and now it's gone. But they're already coming. We will be hearing a talk from two absolute juggernauts of the NEOS community. There's absolutely no point in introducing them at all, because you definitely know them. You've definitely been in their talks, and if you haven't, you're very new here. And I think they're both ready. So give a kind and warm welcome to Bernhard and Marc Henry.
Hallo.
Please, nicht so weit rüber.
You may stand here,
Achso.
this area. And
There's a sign. Please remember to submit your questions so that we can tie up all loose ends when they are done telling us about all of the smart things. Yes, you'll get a clicker in 1 second.
You need one?
Thank you.
Control.
Wie sollen wir jetzt klicken? Okay, hello everyone. Nice that you're here together with us. Or how would you say it? Hello, fellow?
Hello, fellow Neosians, and welcome to something a little bit different this year. This will all be about a project that has been running for the last several years, and but mostly in the shadows of the larger ones like the NEOS event source content repository and NEOS 9. It's now reached a level of maturity where we would like to share it with you all, CPX and the component engine.
Yes, in the shadows, that's the right point. And it's about rendering, let me say as much to you right now already. And rendering is something we hold very dear in NEOS. There's so much effort in the past years, and since the creation of NEOS, there was Fusion, AFX, and Fluid. There was always a strong interest to make rendering something special and something really precise. And yes, now let's look into what we are.
So who are we? We are PackageFactory. That's basically just another subset of the NEOS community, maybe comparable to FlowPack, but a little bit more with an experimental touch. So there's Martin over there, actually. He's a colleague of mine at Zeitgeist. You probably know him and a lot of his contributions to PackageFactory. And for CPX, he's a really valuable a sparring partner for our ideas with lots and lots of insights and experience with doing stuff in Fusion. Then with me on stage is Marc Henry. He's self-employed, and you know the joke about how web developers write a blog, right? So first they start creating new blog software, and then they don't write a blog posting. Marc Henry, on the other side, chose NEOS for his blog, then rewrote the Fusion parser, joined our efforts with the event source content repository, then CPX, the new rendering engine, and then didn't write a blog posting.
Yeah, that's true. That's unfortunate. But let me tell you something way more exhilarating about Wilhelm. Wilhelm didn't even write a blog post, but he did write this new CPX we're about to tell you. And it came to that we need a parser. And the first parser was written by hand. And then there were new requirements, so we need a second parser. Eventually, it got so tedious to write custom parsers for the project because it was the third or fifth manual parser that Wilhelm actually built a LR1 parser library from scratch. I saw the box on his nightstand. This is not... Try that. And more importantly, you here also with me on stage. You're Bernhard, at Zeitgeist, and you have also this little side project, I'd say, for the Star Trek, your fan club, the Starship. It has grown to be more of a little side project and now spans from 40 to 50 distribution packages, runs on the latest tech, ECR, and CPX.
So why are we doing anything of this? Isn't everything fine in the Neos rendering stack? So we prepared our own little version of the Neos demo, slightly improved, of course. And you can already do lots of stuff, right? There are lots of features. You probably know this page. That's the Neos demo page. And for example, you can edit text, right? Just simple text. Everything's fine here. Nothing special, right?
I think, Bernhard, I think the text below, something's missing there?
Do you think so? I guess, that's just text. That's not so important, right?
But
let's have a look at the blog instead. Do you know this?
does anyone have ever felt like this? Missing content? No one? No, you all have.
So let's have a look at the blog instead, right? What could possibly go wrong with the blog?
Oh, wow, Bernhard, I think we misconfigured the server. Maybe the PHP version is out of date. I don't know what happened here. Something really wrong.
Let's have a short look in the exception log. It says someone tried to put multiple things where only one thing was expected. That's just a rendering issue.
But wait, isn't it totally... why are we doing any of this? These kind of errors, they seem totally avoidable by design if we were just to use static analysis. I heard there will be a talk next day, writing strongly typed PHP by Andre, and it will explain us how we don't need unit tests all the time, but we can just, with static analysis, eliminate a lot of bugs, including those we saw.
So somehow, in the presentation layer, right, when we render stuff, then all this safety ends, right? We just want to write text, and then some more text, and then insert some text, and we don't care about types at all, and then something like that happens?
Which is quite ironic. Everything else we built, like an importer, an MPE endpoint, controllers, all the kinds where the backend brains have to put all the effort in. This is beautiful typed software, and just when it comes to outputting, the block import works, but it doesn't show anything.
I guess we just always did it this way.
How would it be if we use PHP for that? Everything.
You might have a point there. I mean, PHP made lots of progress when it comes to types. We now have enums, read-only classes, and so on. And we already store typed information. For example, if you edit your blog post, you might have an image. That's an image, obviously, and not text. Or a postal address, which is a bit more structured than text. We could use that for rendering. So let's do everything in PHP. Let's render in PHP. That is what it was designed for in the first place, right?
Let's try. OK, something really simple. Let's try to follow us here. I show you a button, and this is the necessary marker for it. Now, this is not really fun. Let's interpolate this string and change the text and also the button type as well as the class later. How would you do it, Bernhard?
How about this? So we have a component called button. It has two props, and it has a render method. It can render itself, right? That's really nice. And you can't do anything wrong. For example, the variant for the button, which is used as the button's type, you can't put anything weird there because you're restricted to that enum, right? That's a fixed set of values that are available. And yeah, you have a perfectly fine button.
And how would you use that?
That's rather easy. We don't have to boot any templating engine. We just create the button, select one of the variants, put some content in there, press render, and we're done.
Wow, this actually looks so precise. Look at this. It's just a new instance with all the arguments and the render function we will invoke later. No extra write. And it's just as easy as that. I think we should agree that we like that. But if we go back to the previous slide, I'm not sure that the rendering of the button should be written like that.
What's wrong about that?
Can we get like some hands here? Who would like to write this manually? No one? You, Bernhard?
I'd most certainly do it.
Okay, but
Been
you're
there,
the
done that.
exception. If you look at this more closely, we can already see a lot of obvious flaws. First, it's overly verbose. Try to maintain a code base with 1,000 components like that. Then, everything has to be done manually. The button tag has to be closed manually. Escaping has to be done manually. The content string is just interpolated there without any escaping currently. That's a flaw. Also, if we look at the next slide, the CSS interpolation becomes quite really fun. Not fun. At first, it's simple. We just interpolate a class, and we have the content prop. Then we try to toggle something with a flag, and then we try to toggle two class names with two flags, and later we also want to switch maybe an attribute flag. This is not it's not straightforward at all, and it hasn't even incorporated attribute escaping. So, yes, I think we can conclude that we don't want to write components like this in HTML.
Okay.
But yes, let's try it with integration. But how would we do that? And this brings us to what this talk is about. CPX. It is a new language. A new language which is defined in CPX files or modules, we call it. And it's heavily influenced by React and JSX, ESM modules, and last but not least, HTML itself, because if we just render HTML here. The whole shape is now quite close to the button we saw earlier, except it's even more reduced here in the first case. We have a content as string prop. All props are typed, and a first level concern to the language. And in the render statement, we define the markup and tell how we use the props and render them out. So to get it up with the PHP example, we would also need an add a button variant. And to do that, we need an enum. And this enum will be also expressed in CPX, if you like to use an enum. So it has to be an CPX module, and we write it like here. It will be also first parsed, analyzed, and transpiled to PHP, like an equivalent PHP enum. And now we can upgrade our simple button to be as equally complex as the PHP case with all the variant now added. We added also a content as slot and not just string, so we can add inline editable components in there, or maybe an icon component if that makes sense to you. And in the render statement, we declare how we want to use that variant and match on it. This is quite precise syntax, and it handles everything we like. Also, HTML escaping, that we come later back to. So that PHP will be usable. The transpiled PHP of the CPX will be usable as such we have seen earlier. Just a slight change that we have the button create static function instead of a new. But this is just great, right?
I like
this is
it.
exactly what we wanted to achieve. And if we now look at the previous problem with the CSS classes, I want to show you how we figured that out as well. Does anyone now React class names, the package, to concatenate class names? I bet. Yes. And a feature like this is incorporated into our language, and it's called CX. You can use that to exactly, precisely toggle your class names, and also for data attribute handling, we have the simple Boolean show or show not feature. So everything should be right where you need it. But the button itself is quite too simple yet. How about we leverage new features of CPX that were never there before? And that is composition as first-level citizen. If we take a look here, we import not only the button, but two other components. I will not go into detail here, but we know the button from the previous ones. And we use the card. We define a card, which is a new component module, which is also analyzed, first passed, analyzed, and transpiled to PHP. And we define all its props as those types which are of the component. In the rendering, we don't have to do anything like to call render individually on these instances, but we can just interpolate them here, and they will be nicely rendered. Do note that these are actual types still at runtime when we pass them to the constructor. So this is where the type safety comes from. In Fusion, if we try to write an equivalent, we would feel ourselves in a place of just having strings around, because they will be rendered at that point. Here we have instances. And it will be really fun to integrate that. Look at here. We first start creating the card. We use our IDE support to see which props come next. Source, alt, title, string. Well, that is easy. All of type string, I can just fill them out. I can also be ensured that I don't forget any props, I don't fantasize about new props, or I don't add values to props which type doesn't match. For the text element, it's also quite simple, nothing too crazy. And if we add the final button, we can also see that the button can be quite quickly imported, and the type also, as well as the content we like to have. Our card is ready to be deployed. Look at that. Also, if we now were to change any of these button components in CPX and rerun our linting, we will quickly find ourselves with some red lights blinking up here and there because something changed. And that is exactly where we want to be, in a place where we can monitor easily these changes and its effect on the integration. The transpilation would look approximately like this. We have our card with a public constructor with all the props, and do note again, these are actual instances for the type safety, and the render method where we do return the final HTML and recursively invoke all nested component render functions. More on that note, you don't need to actually understand this whole slide, the whole code, but you will see that there's not a single runtime dependency except for our component engine itself, which is just a zero dependency composer library, and thus this component is completely framework independent and can be used everywhere within PHP. That's nice. So you have seen now bits of the CPX syntax and how composition works. Now let's talk about our design goal of why and what language we were trying to create. We defined it as that CPX ought to be an uncomplicated, type-safe language for writing immutable and side effect-free presentational components which render intact, safe HTML. Well, these are a lot of hairy words. Let's go into the ease of these individual and talk what we mean by them. First, uncomplicated. We believe, quoting the Zen of Python, that explicit is better than implicit, and there should be only one and one obvious way to do something. Also, we believe that the syntax will be easy for front-end devs to learn due to its close nature to previous front-end languages like JavaScript, JSX, and React. Next up is the type safety. And we can say, you have seen that CPX has its own type system. That goes as far as that everything you write within a CPX class will only be transpiled to PHP if it is in itself already coherent and correct. Otherwise, the transpilation will fail. This is really important to get. This is not optional; it's an optional feature, our strict type safety. It's implementation of the whole transpilation. There are no uncovered code paths. We will not expect any runtime exceptions, because every time we transpile the code to PHP, we first ensure that the types can only be of these kinds. Then we do the little matching, and then we have the final PHP. Every code path here in the generated PHP is allowed to be run and works. That is the promise of CPX. And while CPX itself, in all the CPX files, in the whole CPX ecosystem, is type-safe, it would not work if it were not obvious to the outside, to PHP. And we do that by translating all CPX types to PHP equivalents. And that works quite well for components and for primitive types. Though coming to lists, like type collections, where we don't have generics in PHP, this starts to struggle a little, but not too much, because we have PHP stan to our safe. Yeah. It will, the CPX transpilation will ensure that everything is obviously ensured by PHP runtime and for the EDA support, but also that the PHP stan, it can use its narrowing to further narrow the types and ensure everything is used correctly. And matching these parts together, we can have everything in its entirety type-safe.
But are we entirely type-safe? No, there's one small village in Neos which holds out against the type safety invasion, which is node-get-property, which returns something. And we'll talk about that later tomorrow.
Yes. Next up is just a little bit about our immutability and side effect freeness. First, we are fully predictable and self-rendering presentation model. You have seen that. If you look at a CPX file, it will be rendered as such. There are no surprises, nothing will be overwritten from somewhere magic, and there will be no side effects from within the code. If you read the code, you can be sure that you have understood it just by reading that single file. That comes with the impenetrable separation from integration. It gets as strong as that you cannot fire a single SQL query from your components, and that is really good. We don't want that. There is not a single way of doing that. And that is exactly what we want, a full separation. It also ensures that your whole component architecture grows better together and gets into the space where you wanted architecture. Also, last but not least, our whole component tree and with the props allows for efficient caching, as there's nothing, not that dark magic expected during the render functions, so we can just cache the whole component tree with all its props and later invoke render. That is really important for some nice features and saves us from all the bugs Fusion cache has with JSON encoding. Last but not least, we have with CPX always intact and safe HTML. There are no broken HTML tags because it's passed, and we escape user input by default, though you can choose to opt out. Let me demonstrate that. Here we have a funny username. Does that sound familiar? Look that familiar to you? And when we create a button, we are safe and sound. And without any of our doing, it will be escaped as we require it to be. So, in conclusion, we can say that our gains with CPX are the following. The type safety we were missing so long as promised for our PHP ecosystem, and within Neos, actual reusability. Our components are not anymore bound to the front-end rendering. If we find ourselves in a place where we want to build a controller for the direct application which pre-renders the search results, or some other part, like a backend module, where we do want this image component for some reason, or like all of our components, we can just do that without booting up another Fusion, Fluid, whatever. It's just as simple as creating the instance and rendering it and composing it together like you wanted to. But the reusability goes further than that, because we are just platform independent from the transpiled PHP, We can use it not within our Neos project only, but within all PHP projects. That comes also to your save if you want to use Flow, or maybe you want to use Symfony, or anything. It's just PHP at that point with one dependency, the component engine, which has no dependencies. Now, that is platform and dependency within PHP. But CPX has a big ambition. Think about the file format we have. It's so simple to understand in comparison to what we have now. It is simple to parse and analyze for anyone who had tried to figure out how to transpile Fusion to Java or C#. I heard there were some people around that. Try that with CPX. You will do it 5 times the time. And that would allow us in the future possibly to use React as target, to use Rust if you're crazy, or anything. So last but not least, the front-end developers are also familiar with the syntax, and now I will think that it's time for something else. Do you think it will be faster or slower than Fusion?
So one thing that also led to further developments beyond Fusion was the fact that Fusion isn't overdoing it with speed, right? So there was, for example, the Ökokiste project by Sandstorm that I remember. They used PHP-based rendering because Fusion just took too long. And that's also something we want to avoid. Because we win something with the type safety and so on, we don't want to lose any more performance. So let's check this. I did a little bit of a test setup with the Neos demo distribution, and just have one side does the Fusion rendering, and the other side does the CPX rendering, and let's see what happens. I mean, you always have to wait a bit of time, because there also always goes a request to the backend server, then there's an actual database operation, because there's a node being created, and then it's rendered. So on the other side, we have CPX, and I guess it feels a bit faster, but is it actually? So the way to solve this question is, let's do some benchmarks. They're not super professional. It's basically just to get you an idea of the relations and what we will end up eventually. So the reference system is my local setup on my notebook, which runs the Neos 9.1. We do 10 samples, just add a simple text node in production context. And Fusion takes about 130 milliseconds, while CPX takes 100 milliseconds. So there's already a 30 milliseconds gap. And this is just the rendering, right? So the whole request takes a lot of time. Writing the node to the database takes a lot of time. And then rendering should actually be the smallest part. The next thing we see is that the pure rendering in Fusion doesn't even make up for the difference. So maybe by accident we also improved the whole implementation of the out-of-band rendering. But so let's have a look at how long CPX takes for the same tasks, and it's hardly measurable. So as you might guess, it's just string concatenation, and PHP can do that very well. So yeah, one could say, okay, that's just booting Fusion. When you do that once, that could take some time, and the rendering isn't that bad. So actually, you can't really measure rendering in Fusion because it's not separated from everything else. So let's do another experiment. Let's add 1,000 text nodes on that page. Same system, content cache off, so that doesn't cheat. Front-end rendering mode, so no wrapping for the inline editing. The content comes from memory, so there's an in-memory content graph active at that moment, so no database I/O. And Fusion takes for the whole instantiation of its runtime and the rendering of the components about 290 milliseconds. And for CPX, that would be 16. The rendering stays almost constant, no matter how many text components there are. I guess that might have to do with us not doing the wrapping, because the wrapping is far more expensive than the rendering, actually. or it might be that we're even so low level that the internal PHP optimization is in action. So that is a very, very good place to be in. It's also in an order of magnitude where it matters more what the operating system is doing in the background than how many components you render. So that looks nice, sounds nice. Who uses this actually? So there's obviously our Neos demo fork, because we needed that as a reality check. So does this work in a real world project? And also we needed it for benchmarking. Then there is the Starship, obviously, because it's mission critical for Starship operations. It cannot fail. There's no place for type errors in the 24th century. Also, it's running on a Raspberry Pi, and it doesn't have the resources to really run Fusion. And then, of course,
there is my blog, website, and yes, this is my personal fate, so I dedicate this to CPX, and it's a good showcase for a really simple project, and it's open source. We will actually go into this in the talk after lunch. Speaking of open source, our code, the component engine, is as well. What else? You can find us at Codeberg in the organization PackageFactory/component engine. And there are already a few alpha versions available. Please do still expect some slight syntax changes, as we are heavily working on new features. Though be assured that we have a plan. We defined all features we like for the 1.0 release, the 4 of us in our yearly meeting in Hamburg.
So it's not just another alpha version. It's quite stable when it comes to reliability. So there might be changes, of course, but it doesn't throw too many exceptions. Exactly 0, I'd guess. Because as every good PHP project, it's mostly written in Gherkin. So there are lots and lots and lots of behavioral tests for caching, for example, and so on, for the Neos integration, and lots and lots of unit tests for the parser and so on themselves. So you can support us if you want. For example, trying out our alpha versions, report bugs, or missing features. Maybe you have some special HTML syntax from several libraries, and we will see whether we can support that or not. For our development, help with the ecosystem. There is still a lot to do, like IDE integration, for example, syntax highlighting, auto-completion, because we know all the props, right, that could work. JavaScript transpilation, maybe design tool export. I could imagine that you have some kind of Figma plugin, for example, that directly outputs your CPX files that you just have to adjust. And yeah, get in touch with us. There's a dedicated Slack channel, the component engine, and you find us on Codeberg and basically for the whole conference around here.
Just talk to us. And as announced earlier, there will be a second talk today from me, basic CPX integration and SDP live demo, as well as your talk.
Yes, in the third episode, we'll touch a few of the fan favorites in the advanced CPX integration, for example, caching, because caching is a lot of fun, right? And we try to solve this node-get-property problem and have a look at the so-called object property graph mapper.
Yes. So thank you all for watching, and that's it.
Thank you. Sure, I'll take that. Just let me, you know what? I'll just free up my hands. You're not getting one now. Because you have so many talks, we can't give you one every talk. But Bernhard is getting.
I think we're both in the same place, I guess. But yeah, thank you.
Yeah, but we need to spread out the gift giving. So you now, you later, but then not you again. Yes.
Yeah.
See?
Thanks a lot. I will. This will have a special place in my backpack because I will never leave without it.
I feel like there's a rule about always having a towel with you. Someone might. Yes. We have a few questions, actually.
Quite some.
Oh, good that we finished.
Do you want to start?
Oh, yeah. So first question is, are you planning on making an IDE plugin?
Sure.
Yes, plugin in sense of a language server, actually, so that you can use it in every IDE. Yes.
But
that's the
you're
plan.
rather welcome to build it also and help us, because it takes a lot of time.
Never done this, so might be one of those community things, right?
Actually, I feel like the IDE integration and syntax highlighting and stuff seems to be a pressing issue because there's more than one question about that. Someone says, I feel like this loses a lot from the overridability from Fusion. Am I wrong?
Yes, this basically completely removes the concept of overridability because components in our from our idea are not there to be overridden but replaced. So if you want to use another component, use another component.
Well, and will CPX be integrated into Neos Core in the future? Speed stats look nice enough for that.
It's way too early to decide anything like that. We are PackageFactory, we are independent, open source. We are just sharing the members with the Neos team, but as long as no one decides that from the outside, it's not time yet.
So I guess we would love to see that in the Neos Core. But we really want to see first how the community adopts this. So do people like this, or do people prefer to stick with Fusion? Let's see.
Very cool, says someone anonymously, very cool. But why is the import syntax reversed from the ES module standard?
Good question, because if you ever watched like how the IDE works for JavaScript, it always jumps first to the name you want to import and to the file you want to import and then back to the name. And we've just reversed it to have a just more natural order. I think the ES module standard is just wrong.
Bold. Can you create a component inside the render segment?
Yes, that is more advanced, but that works. Not for collections, though. But you can delegate if you want. It's rather recommended that we instantiate everything from the integration and pass it along.
Okay.
Type safety in rendering is one side, but what are the guarantees to the content received from node types?
Yes, I love this question because I have a whole talk about that.
Such a smart audience.
Yeah. Yes, this is an issue CPX can't solve. The component engine itself can't also not solve this. But we need some kind of layer around the content repository for that. And that's exactly the topic for my talk tomorrow.
Cool.
So you anticipated the question. What a great cliffhanger.
And then there's the last technical question. Why use classes and instantiation instead of using render functions with the properties as parameters?
That is a good question, but that is the approach that React and Fusion took, and they are both flawed in the way that they just can instantiate something and they return a generic result, like a string for every component, or in React, like a rect instance, rect element for every. And that is not typed anymore. If we pass it around, it's just a string. We don't know what it is. If we debug it, we just see the string, but we don't know it's an image. We lose the identity. And that's why we use self-rendering components.
All right, we have one last question that is signed with thanks, Marc. So either Marc asked the question or they're thanking you specifically. They're asking, is it possible to extend the compiler to decorate all components?
To decorate?
Is it possible to extend the compiler to decorate all components?
We need to get into detail what you mean with decorating, but yes.
I mean, probably not make it prettier. All right.
So definitely not a feature for the 1.0. No.
Or a question that you can explore further with Marc, maybe.
Yes.
Over a coffee. That's it. That's all the questions.
You definitely sparked a lot of inspiration.
Yes.
Thank you.
Thank you so much. Now, please remember to rate the talks. As usual, for the Android users, keep doing it in the comments. As you see, they are obviously anonymous. Yeah, thank you so much. We are looking forward to your other talks. And then you'll also get a present, I promise.
Dankeschön.
All right. We have a quick more break, and then see you in 20 minutes.